In this section, I'm going to talk about two filtering features, two route filtering features that iOS provides us with that allows easy filtering of routes. These are prefix lists and route maps. First, let's talk a little bit about prefix lists. Prefix lists give us flexible and simple route filter definitions. Now, what do I mean by route filter definitions? Sometimes we have certain routes that we want to advertise to certain neighbors, regardless of the protocol, and some of the routes that we would have been advertising to this neighbor, we do not want to advertise. So somehow we have to identify these routes and we have to configure our routers to not advertise these routes or to filter them out. And we can do this in inbound or outbound direction. Now, when it comes to specific filtering features in different protocols, I'm going to talk about that separately, but these definitions for route filters, these are generic and they can be implemented using several different methods. We can use the access list, but access lists are generally speaking not well suited to filtering routes. They are well suited and designed for filtering the actual traffic. When it comes to routes, using access lists for filtering may not be as intuitive as you think it might be. And this is the reason why Cisco came up with this idea of using prefix lists. Now, when we are using prefix lists, it's important to understand that they consist of several parts. The first part is the actual route that we are filtering, then the prefix length that we want to filter on, and then a particular match definition. Now, allow me to explain this a little bit. There are, generally speaking, four things that can be done with prefix lists. We can have the exact match, we can have a match of a particular route from a certain range up to a specific prefix length, or we can have the similar thing with a minimum prefix length, and finally, as the fourth item, we can have a range of prefix lengths. So what am I talking about here? So let's take a look at these couple of examples. So for example, for the exact match, let's say that we had a route 192.168.0.0/16 that we wanted to permit in some way. The prefix list definition for that particular case is here and in our prefix list number 1. And this is the syntax that prefix lists always have. We have IP prefix list, then we have a particular name, we have an action to take, and then we have here a route definition. What I mean by route definition and what I meant when I said it, when I was talking about this part here, this is more like a route seed definition. Now, what do I mean by route seed? This simply means whatever I'm doing about this route, the routes that are going to be matched against this particular rule need to come from this range of routes. And in this case here, we are defining an exact match because we don't have any other action that follows here. So with this definition, with this definition of IP prefix list PL1 here, we are going to be matching only 192.168.0.0/16 route. But let's say that what we wanted to do is we wanted to match the routes from 192.168.0.0/16 length, but we didn't want to allow all the routes. We wanted to allow only those routes that have the range of prefix lengths from /16 to, say, /24. So we want to allow only those prefixes that fit into this category. If we wanted to do this, this would be a prefix list that we would use. And we can see here IP prefix list PL2, so we are just giving it a name. We are permitting prefixes from the range 192.168.0.0/16, and here we have an operator LE24. LE simply stands for lower or equal. What we are saying here is that we are going to allow prefixes from this range here as long as they are between the prefix length of /16 and up to a maximum length of /24, which means that we are going to allow /16, /17, /18 and all the way to /24. But if we had, say, /25 prefixes or /30s or /15, for example, that began with 192.168.0.0, those prefixes would not be allowed by this rule here. In some cases, we want slightly different behavior. Let's say that we wanted to allow prefixes from our 192.168.0.0.16 range, but only those that were /24 or longer. That means that they had a longer mask, so /24, /25, /26, and so on. If we wanted that particular behavior, instead of using LE, we can use GE operator, and GE simply stands for greater or equal than. So given this syntax here for prefix list PL3, we are going to allow all the prefixes from 192.168.0.0/16 range that have the prefix length of /24 and above. So this would permit /24, /25, /26, all the way to /32, as long as the route comes from 192.168.0.0/16 range. And last example is probably the one that is most difficult to understand. And let's say that in this case we wanted to permit all the routes from 192.168.0.0/16 range that had the prefix length between /24 and /26. So we want to allow only /24s, /25s, and /26 routes, as long as they are coming from this particular range here. If we wanted this particular behavior, we would use GE and LE operators together. So our prefix here, so if we had a prefix that we wanted to match, actually needs to be greater or equal than whatever we specified as the GE value, and it needs to be lower or equal than whatever we have specified as our LE value. So another hint here, when you are using this, when you are not sure whether you need to type GE or LE first, keep in mind that GE needs to be lower or equal than LE value. Otherwise, iOS is actually going to reject this syntax. I know this may sound like a little bit too much given these abstract examples, so let's head into iOS and take a look at a couple of examples. I'm now going to head over to my terminal, and what I'm going to do here is I'm going to look at some of the pre-configuration that I have. I have two routers, R1 and R2, that are running EIGRP between them, and R1 is injecting some number of routes into my routing protocol. I don't care about R1 at this moment, and I don't really care about EIGRP configuration as such. I'm just going to focus on the behavior of prefix lists now. I will talk about filtering in EIGRP in just a moment. So if I take a look at my R2, if I do show IP route EIGRP, I'm going to see here that I have all sorts of routes that are coming from 192.168 range. I have 192.168.0.0/16, I have a number of /25, /24, /26, all sorts of routes with prefix lengths. I even have /15 route there. So let's now configure R2 using a prefix list, and I'm going to call it PL1, just like in my previous example, to allow only that /16 route. So I want to filter out everything else. So what I'm going to do first here is I'm going to start configuring my prefix list. I'm going to say IP prefix list, and let's call it PL1. I want to permit 192.168.0.0/16. So with this prefix list now, and I can see it, if I do show IP prefix list, I can see how this is configured. Now I have the filter ready to be applied, and I'm going to go to EIGRP here, and I'm going to use a simple filter. So it's going to be distribute list prefix PL1 inbound. So what I want to do now is I'm applying this prefix list PL1 on my neighborship. So this is going to apply to all the routes. So with EIGRP, I have to wait a little bit for the neighbors to resynchronize, and there I have it. So if I do show IP route EIGRP, I can see now that all those routes have disappeared, and the only route that I have right now is my /16. Let's take a look at some other examples. Let's now allow this /16, and let's allow all the routes, say up to /24. So I don't want to allow any prefixes that are longer than /24. So I want /16, /17, /18, and so on up to /24. So let's configure our prefix list. But before I do that, let me remove this one, because we can have only one distribute list, prefix list applied in the inbound direction or the outbound direction for EIGRP. So let's say IP prefix list, let's say PL2, and I'm going to permit 192.168.0.0/16 lower and equal than 24. So now I'm saying that I want to allow all the routes that are coming from this range here, as long as their prefix is between /24 and /16 in length. So let's take a look at what else I can do at this moment. So I'm going to go to router EIGRP, and I'm going to apply my prefix list PL2 in the inbound direction. And again, I have to wait a little bit for the neighbors to resynchronize. When that happens, there we go, I'm going to do show IP route. And what I'm seeing here now is a subset of routes. I can see that I do have my /16 and that I have a number of routes with their prefix lengths here that are between the range of /16 and /24. A very important thing to note here is take a look at the third octet here. The third octet here is not really taken into account. What we are saying here with our prefix list is take a look at this range, and all of these rounds are in that range, and then focus on what is the length of the prefix here. We don't care what's in there in the third octet. Let's take a look at that other example, example number 3. So let me remove this distribute list here, and let's now configure our filter to allow the routes from 192.168.0.0/16 range, but that have a minimum prefix length of, say, /24. So I want /24, /25, /26, and so on. To do that, I'm going to create another prefix list. So this one here is going to be prefix list 3, and instead of using LE, I'm going to use GE operator here. And again, I'm going to go to router EIGRP, and I'm going to apply the distribute list PL3 inbound. So let's wait for the resync. And once that happens, I'm going to take a look at the routes. So this usually takes a couple of seconds. There we go, it resynced. So now, if I do show IP route EIGRP, now I have even more routes than before. But if I take a close look, I will see that all of them fit into my definition of prefix here. They are all /24s or a longer prefix. And I can see that my /16 route is now gone because it does not conform to these rules. So now I have all the prefixes starting from /24 and above, and I can see here. Again, a thing to note is that the third octet here is not taken into account. It's only the prefix length and the actual range that we have specified. So all the routes need to come from this particular range, and they need to have a prefix length of /24 and above, greater or equal than that value. Let's now take a look at the last example. What we want to do here is, actually, let me first remove this distribute list here before I create a new prefix list. There we go. So I'm going to say prefix list, let's say prefix list 4, I'm going to say permit 192.168.0.0/16, and what I want to do here is I want to specify the routes that have prefixes in the range of, let's say, /24 and let's say /27. So I may not be using the exact same example that I had before, but let's use this one here. So router EIGRP 12, and I'm going to say distribute list, prefix list 4, inbound, and I'm going to wait for EIGRP resync here. And when it happens, I will take a look at the routes. There we go, the resync happened. So now, if I take a look at my routes here, I will see that I have /25, /26 here, and that I have 24, 25, 26, and 27 here. But you might remember in the previous example we had any number of /28s, we had /29, /30s, and so on. But all these are now gone, because now I'm saying that routes from the range of 192, 168, 0, 0, /16 are going to be allowed as long as their prefix is in the length of /24 to /27. So anything lower than this or anything higher than this will not be allowed, but the routes still need to come from this particular range. That being said, prefix lists can be even a little bit more involved. First of all, there are certain number of actions that you can take with prefix lists. You can allow certain prefixes, you can permit them, or you can deny certain prefixes. And that's specified with the prefix list action. In all of the previous examples, we were using the permit action, but we can also use the deny action there. Prefix lists also support having multiple entries. Now, multiple entries in the prefix list allow us to solve tasks like, for example, this one here. Let's say that we had a task that said permit all networks from 10.0.0.0/8 range except those from 10.10.0.0/16 range. So I want all 10/8 networks to be allowed, but if there is a 10.10/16 network or any subnet of it, I don't want to allow these networks here. So what I can do here is I can specify a prefix list, and you can see here that this is a prefix list 5 in both cases that has two sequences, 10 and 20. And keep in mind that this sequence syntax here is not mandatory when you're actually typing out the prefix list, but it will be entered for you by iOS there. But I think it's a good thing to remember that there is this sequence syntax here, because then you can insert the entries in between if you need them down the road. So the logic here is, first we are going to deny 10.10.0.0/16 lower or equal 32. So here we are saying anything that comes from 10.10/16 range, so /16 or above. So we are saying any prefix that comes from this particular range is going to be denied. And finally, in our sequence 20, we are going to permit everything else from the 10.0.0.0/8 range. But keep in mind that prefix lists are processed sequentially according to the sequence numbers there. So if we had 10.10, it would have been denied at this point, so it is not going to be permitted by this entry. It's very important not to forget this, and that you might write this prefix list in the wrong order. Another examples that I want to give you are special cases. Like, for example, if you wanted to permit any route, regardless of what the route is, you can use this syntax here. So in our prefix list PL6 here, we are permitting all the routes. How does this logic work? Well, let's take a look. We are permitting the routes from this range, and this here specifies all the routes, and we are saying use any prefix length from that particular range. So basically, we are saying here that this matches all routes. If you ever needed to allow or deny certain routes, or allow or deny all the routes, if you needed that syntax, this is the syntax to remember here. To contrast this, if you wanted to permit or deny the default route, this is the syntax that you have to use. Because remember, the default route is 0.0.0/0. And this needs to be the exact match. And with this syntax here, we are providing the exact match for the default route. Also, you may have concluded this from my examples before, but I'm going to go out and say it. Do not forget that all prefix lists have an implicit deny at the end. Anything that is not explicitly permitted by prefix lists will be denied. you can, for sake of your sanity, when you are writing prefix lists, you can go and at the end, instead of relying on an implicit deny, you could add an entry at the end that simply looks like this, but you don't have to do it. The prefix lists have already done it for you. Prefix lists are very flexible. They allow us a lot of flexibility, but sometimes they cannot actually solve anything or everything that we need when it comes to route filtering. If we need more flexibility than this, we have to look at other features, like for example, route maps. Route maps are offering us even more flexibility in filtering routes than prefix lists would. What we can do with route maps is we can not only reference the routes using prefix lists like we can with prefix lists alone, but we can use access lists or prefix lists, or the route types. Is the route internal or is it external? We can match based on a specific metric or the metric type. We can match based on IP next hop, BGP attributes, and so many different things. And we can either permit or deny routes based on these criteria, and route maps are, similarly to prefix lists, processed in a sequential fashion. What route maps do though, and prefix lists as well, is the first match processing. That means if the route map entry, whatever is the match criteria inside the route map entry, if it is satisfied, the route map processing ends and the action permit or deny will be taken. But with route maps, we can be even more flexible using a specific configuration called the continue statement, in which we can say, if this entry is satisfied, do not exit processing at this point, but proceed on with another route map entry, and we can specify which sequence to use. So let's take a look at a couple of examples of route maps. So in this first example here, let's say that we wanted to permit routes from the range of /24 to /27 if they are coming from 192.168.0.0/16. Now, this is something that we have done with prefix lists before, so our prefix lists entry would be like this, and then inside the route map, we would reference it like this. So we would define a route map with the name RM1 in my case, and we want to have an action permit and the sequence of 10. So in this route map, we are then going to specify what is it that we are going to be matching. And we want to match the IP address, and in this case, IP address keyword is used to match really the route. And we are telling our router to use the prefix list that we defined here, prefix list PL1. Now, given this particular example here, it makes no sense. Why did we use the route map and not use prefix list? Well, because of some limitations if we use prefix lists directly in the filtering mechanisms. You may remember that I mentioned just earlier that in example of EIGRP, when I'm configuring a distribute list, I can specify only a single prefix list inbound or outbound. But if I wanted to have, for example, prefix lists that I want to use in multiple interfaces for filtering, but on one interface I wanted to use multiple prefix lists, I couldn't do that. But with route maps I can, because I can say, okay, for this sequence, for sequence number 10, use prefix list PL1, but when I define, for example, sequence 20, use prefix list PL2, and so on, and so on. So route maps are offering us more flexibility, but that does mean a little bit more typing to begin with. But let's take a look at another example here. Let's say that we wanted to deny /24 to /27 from this particular range, but only if the routes are internal EIGRP routes, or internal routes, or whatever protocol we are using. And let's say that we want to allow external routes from the same range. Now, using prefix list alone, in this case, won't do, because with the prefix list we can only match the particular range and the range of prefixes, but what we cannot do is we cannot match on the route type. But if we use the route map for filtering, we could simply say here that yes, we want to allow the internal routes, but here, or we want to deny the internal routes, but here we want to permit the external routes. So let's take a look at this logic. First of all, I have my route map RM2 that has two sequences, 10 and 20. Now we can see that the first sequence has the action of deny. That means whatever is actually permitted by the prefix list that I'm matching here will be denied because this here is a deny statement. Now I could also use an inverse logic. I could have, for example, in the prefix list, prefixes that said deny this range and permit everything else, and here I would have permit instead of deny. That means that routes that are actually not from this range would be permitted, but those from that range and that are internal would actually be denied. So kind of an inverse logic. Sometimes it could be a little bit difficult getting your head around this logic, but for me this approach is most direct one. I'm going to have a prefix list here that actually permits, that specified the range that I do want to take a particular action on, and then in the route map I would take that specified action. So I'm going to deny whatever this prefix list permits. So in my prefix list I'm specifying this range here, and if the route is internal it will be denied because this is the logic that we specified. Now in the second route map entry with sequence 20 I'm saying permit whatever this prefix list permits, and if the route is external. So when we have multiple match entries here, they are organized with a logical AND operator. That means that this must fulfill the requirements and this here must fulfill the requirements. Now, how would the route map look if I wanted to use multiple prefix lists? Well, let's say that I had a prefix list 2 in this case. Now, in this case, when I specify match IP address prefix list PL1, PL2, there is going to be a logical OR operator here. If I wanted to have a logical AND operator here, I would have to go through a little bit more effort. I would actually have to use that continue statement here and say continue processing in the next route map entry. But looking at all this like this makes no sense. Let's go to the terminal and try these two out. In my terminal on R2, the first thing I'm going to do is I'm going to take a look at what kind of EIGRP routes I do have. And here I can see that I have a mix and match of internal and external routes. So let's go back here and take a look at our example. Let me type out the prefix list that allows the routes from this range here, and then let's try route map 1 to see what that's going to do for us. So I'm going to go here and I'm going to say IP prefix list PL1 permit 192.168.0.0/16, and I believe it was GE24 LE27. So we want the range between 24 and 27, and then let's say we want to use route map 1 permit 10. You don't have to type permit 10, that's going to be implied action. And here I'm going to say match IP address. Now if I specify just the name or the number, that's going to be an access list reference. So be on a lookout for this. If you want to use prefix lists in route maps, you actually have to explicitly say that you want to use a prefix list. And I want to use prefix list PL1 here. So I'm going to go to router EIGRP here, and I'm going to say distribute list route map, and I want to use route map 1 inbound. And again, I have to wait for my routers to resync because this is EIGRP. And when that happens, eventually, there we go, I'm going to say do show IP route EIGRP, and now I can see that I have again mixed and match of internal and external routes, but they are all from /24 to /27 range. All the other routes have disappeared. Let's try our route map 2 now. The first thing that I'm going to do now, I'm going to remove this route map. Similarly to prefix lists, you cannot have multiple route maps applied. You can have only a single route map. But with the route maps, you have a lot of flexibility what you can do in them, so that's not really a limitation. So what I want to do here now is I want to retype all this configuration here. So I'm going to say route map rm2. Now this is going to be deny action here, and I want to say match IP address prefix list PL1. I can reuse the same prefix list now, and I want to deny internal routes, and I want to have permit 20. Now if you want to create additional route map entry, you need to type the action and the sequence number, otherwise the default is going to be permit 10. So if I just typed route map rm2, that's the equivalent of typing route map rm2 permit 10, and this is not what I want. I want now the second entry here, and what I want to do is I want again match IP address prefix list PL1, and in this case I want to match route type external. So if the routes are internal and they are from that particular range, they will be denied, and if they are external from that particular range, they will be allowed. And then I'm going to go to router EIGRP12, and I'm going to say distribute list route map 2 in the inbound direction. And again, I'm going to wait for my EIGRP to resync. And when that happens, let's take a look at the routes. And I can see here that I only have the routes that are from /24 to /27 range. So I have 24 and 25 here, but only the external ones. All other routes have been denied. A thing to note here, similarly to prefix lists, here at the end of our route map, there is an implicit deny. There is no particular sequence number, so I'm just going to write end here. There is an explicit deny everything. So when you are using route maps, if you have only the deny statement in the route map, if you don't have a single permit, it's kind of pointless, because if you are denying something explicitly, you don't have to do that because there is a deny at the very end. All you have to do is just create the route map with an empty deny statement, because that would be the equivalent of it. But if you want to permit a certain thing and then deny everything else, then it makes sense. But be very, very careful if you need to do something that denies a specific thing and you need to allow everything else. If that is the case, what you need to do probably at the end of your route map. So let me use the whiteboard for that. So if you had a task, if you wanted to do something that says deny x, whatever x might be, and permit everything else, what you need to do is really, you need to create a route map that is, say, deny, for example, 10. You're going to say match whatever x here is, and then you would create a route map permit. And I like to leave some room in this case, so I'm just going to put the sequence number 99, and this is it. You don't put anything there. This empty permit statement is kind of a catch-all at the end of the route map that is going to allow everything else.